Well, hello again there, and welcome to this maths class presented to you by O3 Schools JAMB app. Now, your O3 Schools JAMB app, as we've been seeing, is simply an application which you can install on both your phones and laptops. And what it does is that it offers you a variety of features which you can use. And some of these features, one which I particularly enjoy is a question search feature. On the question search feature, you can actually go there and to be search for any particular phrase or keyword which you remember in that particular topic. What the app does is that it brings out every question Jam has set that may have that word you're looking for. You can try search by topic, by explanation, depending on where you think that word should go in. So if you like, you can go there and search for a topic name and expect to see the questions as regards that topic. There's also the information aspects of the app where you are given information about different schools, the courses they offer, and the requirements for those courses. But very importantly, it is a CBT app. That means it's an app which helps you to practice your computer-based tests. JAMB is a computer-based test, and this app gives you a platform which looks pretty much the same as what you see on the day of your JAMB for you to practice. So if you're not particularly computer savvy, you're not sure how some of these things work, you could run it with your O3 Schools JAMB app. And after practicing several times with the app, there's no way you get to the center of the day of your exam and be confused as to what to do. No, you'll be used to it, you'll be comfortable, and you'll be ready. But more than just offering you these questions for you to answer, the O3 Schools JAMB app lets you actually bend or arrange these questions however you want. You could alter the time, increasing the time, reducing the time to test yourself. You could adjust the number of questions, and you even can choose the particular topics you want questions to be set from. So not just choosing the year of past questions, we don't tell it give me questions purely from this topic across all years, and the app will do that for you. And even more, when you see your answers after you are done, it gives you breakdown of how you answered. The ones you got right, the ones you failed, how long you spent on different subjects. So you actually know where you are lagging behind and where you are performing well. All these and more are available to you within the O3 Schools Jamba app, but only after you activate. Activating the app is very important. If not, you find yourself extremely limited. And activation costs the sum of 2,500 naira only. That is all you have to pay to activate every single thing within this app. So, as you are aware, this is very, very cheap. This is launch money. This is less than the money you will spend buying your hard copy past questions for all four subjects. But yeah, this gets you every single subject, and you're actually able to work with the app and do very well. So get your app, activate it using any of the payment methods you see within the app, and your app is 100% guaranteed to open and start working perfectly fine for you. And I assure you that when you are done, you'll come back and give testimony as to how the app helped you with your exam. And with that, let's head to today's topic. And in this class, we shall be looking at applications of differentiation. So, we've learned how to differentiate, how to find derivatives. What about the uses of these derivatives? Are we just finding them for fun or for nothing? No, there are several aspects where these derivatives are useful. And number one is in finding the slope, also called the gradient of your graph. If you have a graph and you want to find the gradient of this graph, differentiation is the easiest method. And you never have to plot it. All you need to know, as long as you know the equation of your line expressed in terms of x, then your gradient m is equal to dy dx. That means simply differentiate the equation of the line and you will get the gradient of the graph. But at times this graph will be a curve, not a straight line, because in a straight line, gradient is equal. But in a curve, it is different from point to point. That means you'll be asked to find the derivative at a particular point. So divide the x at the point they want gives you the gradient in exact figures for that particular point. So this is one key thing you can do with differentiation. Two is analyzing motion. You can use differentiation to analyze motion. Say you are given the displacement in terms of x. So you are given distance, so let's call it s as they do in physics. Given displacement s as a function of x. Though I think we just prefer to write it as x over here. We'll make it easier when I'm explaining things further. That simply means, because in this case now, when you look at differentiation, the distance is actually a function of time, t. Your distance depends on time. Rather use that x equals to a function of t. Sorry for putting x here before. Your displacement x is a function of time. And as such, the velocity, the speed of movement, is equal to the x, the t. Now, to find the velocity, simply differentiate the expression for the distance. While to find the acceleration, simply means you have to differentiate the velocity with respect to time. And since we know that the velocity was already the derivative of the distance, that means you are finding the square x dt squared. So this is how we use our equation, or rather our differentiation, to actually analyze the motion of a body. So not just can we use it to find the gradient of lines, we could also use it to analyze motion. Next up, we could also use this to analyze change in areas and volumes. Change in areas, analyze change in areas and volumes. Change in areas and volumes of shapes. You can use differentiation to do that. And this basically works by saying, if I find a change in area to be rate of change in area equals to the derivative of the area with respect to the part of it that is changing. Typically, there is a circle. If I have a circle right here, this circle has a radius. What happens if this radius begins to increase gradually? That means my circle as well will be increasing gradually. Therefore, what I will have, I'm finding the rate of change in area, it becomes dr multiplied by the rate of change of the radius. So the derivative of the area with respect to r times the rate of change with radius. That must not be r, but commonly in JAMB, this is what they use. For example, let's say I deal with a sphere, or something, or a cylinder, something that has radius as well. Then the rate of change of the volume of the cylinder, or the area, in this case let's try volume, would be dv the arrow still times the arrow dt. In a cylinder, as you are aware, a cylinder has both radius and height. If it was changing height to be dv dt equals to dv dh, because now I'm dealing with height, no longer radius, times dh dt. But the idea is constant. You simply give yourself the expression for either the area or volume, depending on what you want, and find its derivative with respect to whatever is changing, multiplied by the rate at which that thing is changing. Now we have one more thing we can apply differentiation to. That's actually one of the most important ones, and that is the turning point of a graph. So this last one, the fourth one, is the turning or stationary point of a graph. So what do we mean? Well, say I have a quadratic graph, it must turn somewhere. This one that looks like U is called a minimum graph because it has a minimum value but no true upper value. This can keep on going up forever. Why this one that should I say is like N or inverted U is called a maximum graph because it has a maximum value up here, but it can keep on going down forever. Cubic graphs, on the other hand, have no such. Cubic graphs have two turning points. We're talking about a cubic graph. This is graph of S squared something. But if the graph is S cubed, it's going to have both a maximum and a minimum point because it has two turning points. If it was x raised to the power 4, which is not commonly given in JAMB, but also possible, then this graph will now have three turning points. 1, 2, 3, or it could have 1, 2, 3. But just know, the number of turning points it has is always one less than the maximum power. So maximum power 2 has one turning point, maximum power 3 has two turning points, maximum power 4 has three turning points. However, how do we analyze? First of all, if you are given the expression for the line as y equals to f of x, then dy dx at x equals to 0, values of x give turning points. That simply means if you have your expression, differentiate it with respect to x. Whatever you get, equate it to 0. And then solve the equation that forms. Whatever you get for that equation will give you the turning point or points. As you are aware, if it was x squared, when I differentiate, my new maximum power becomes x, and I get one answer, now one turning point. But if it was x cubed, I get x squared, two answers, two turning points. So, one more time, once I differentiate my expression for the line, whatever I get, I equate it to 0. If I then solve for the values of x in that my expression, that would give me my turning points. But that doesn't tell me which type of turning points they are. Are they maximum or minimum? To find that, I simply find the square y, the x squared. That means I differentiate the y, the x again. When I differentiate, if I get an answer less than 0, then I know that it is a maximum point. While if I differentiate again, and I then get an answer greater than 0, then I know that it is a minimum point. So that's how that works. Once I get my turning points, if I want to know the nature of those points, then I differentiate again and put in this my value for my stationary point, by the way. After differentiating again, I have to put in the answers I got here. So basically x equals to, let's call that t dot p, which is turning point. So I'll go through it one more time for emphasis. I get the equation for the line. I differentiate it. I equate it to 0. Whatever I get for x is going to be the turning point. But I'm not going to know which type of turning point it is, maximum or minimum. So what do? I differentiate again. After differentiating again, I put that my value of x into my expression. If the answer I get in this case is now less than 0, then I know that I'm dealing with a maximum point. If the answer I get is greater than 0, then I know that I'm dealing with a minimum point. So that's how it works. While if I want to then get the actual value, be it maximum or minimum, I simply put my value for x here into my original expression. I know this may sound a bit confusing to try and remember because we're just being theoretical right now. But once we solve, we're going to observe it for yourself. So for now, please note these. Remember to note those we cleaned before. And once you note them all, it's time for us to open our O3 Schools JAMB app and actually solve some questions. Now, I said this way we looked at differentiation, but this is one of those topics in mathematics that you really have to solve as many as possible, because the more you solve, the easier it is for you to remember. Okay, my first question is from the year 2002, and this was question 17. And it says, the slope of the tangent to the curve y equals 3x squared minus 2x plus 5 at 1,6 is what? To find the slope of this graph. I know slope and gradient are the same thing, and that gradient is equal to dy dx. That means finding dy dx, differentiate that. Differentiate 3x squared, 3 times 2 is 6, that will be 6x. Differentiate 2x is 2, and 5 is 0. However, how do I know what value to put? This is a coordinate system, 1,6. In a coordinate system, x always comes first before y. That means y is 6 when x is 1. But the value I actually want to use is 1. So I'll find dy dx at the point when x is 1 would be 6 into 1 minus 2. 6 times 1 is 6 minus 2, and that is 4, which is option C. So you see, very, very easy. Let us proceed. This time we are going to the year 2001 and taking a look at question 33. This one says, if the gradient of the curve y equals 2kx squared plus x plus 1 at x equals to 1 is 9, find x. If the gradient when x equals to 1 is 9, I'm to find x. But however, if I do that, let's first of all find this gradient I'm talking about. I know the gradient is dy dx. So dy dx is going to be 2 times 2 here is 4. K is a constant, so it's unaffected. That's 4k. Then 2 minus 1 is 1. So 4kx. There's an invisible 1 here, of course. Differentiate x, you get 1. Differentiate 1, you get 0. And now the gradient was given to us at the point x equals 1. That means dy dx at the point x equals 1 will be 4k times 1, x is 1, plus 1. And note that this gradient ought to give me 9. That means 4k times 1 is 4k plus 1 equals 9. 4k equals 9 minus 1. That is 8 over 4 over 4, and k equals 2. Which, when I check my options, is option C. So you see, truly and very, very simple. All right, let us proceed. This time to the year 2002, and we're looking at question 21. This one tells us that a circle has a radius of 5 centimeters. Radius is 5 cm, and its radius is increasing at the rate of increasing of radius is always dr dt at 0.2 centimeters per second. What will be the corresponding increase in area? That means I have to find the a dt, the rate of increase in the area of the circle when the radius is increasing at a rate of 0.2. Now, like I said, before you can solve any question at all on that rate of increase, you have to know the expression for that thing they are looking for. You want to find rate of increase in area, so you have to know the formula for area first of all. Area of a circle is pi r squared. Very simple. And since the radius is what is increasing, then I must find the arrow. That will be, arrow is now my variable instead of x. So this is 2 power 2. 2 times this constant, which is pi, is 2 pi. Then arrow, 2 minus 1 is 1. That means this is the arrow. And so that arrow is 5 cm. So the arrow at arrow equals 5 becomes 2 pi times 5. 5 times 2 is 10 pi. And why did we do all this? Because we know, as we wrote down before, that the t is the arrow times the arrow t. The arrow, as we solved, is 10 pi. And the arrow t, as we were given, is 0.2. 10 times 0.2 is 2 pi. And this is the rate of area, that will be centimeters square per second. And if I check my options, that is option B. So you see, under the applications, it's very, very simple. Just know the necessary method you need to apply and apply it. But before you can apply it, you have to know how to differentiate. So if you are here without watching the video on differentiation, please go back and check that out. And you realize that this is actually very simple. Okay, this is our fourth question. This one says, if the volume of a hemisphere is increasing at a rate of 18, if the volume is increasing at a rate, so the rate of increase in volume is 18 pi meter cube per second. That's the rate of increase in volume. At what rate is its radius changing? I want to find the rate of change of radius when the radius is 6 meters. Just like before, we know that, let me write down the formula here. The v dt must be the v, since they said it's radius that is changing, the arrow times the arrow dt. Is that before I can actually come myself for the arrow dt, I have to find the v the arrow. What's the v the arrow? I have to know v first of all. And this is a hemisphere. A hemisphere is half of a sphere. And it has a formula for volume, which is 2/3 pi arrow cube. As such, the v the arrow must be multiplied by 3. 3 times 2/3 pi arrow cube minus 1. 3 here cancels 3 there. That leaves me with 2 pi arrow 3 minus 1 is 2. But I know that, let me quickly do that here. I know that my radius is 6, as I was told in my question. So that must be 2 pi times 6 squared. And 6 squared is 36. So that is 72 pi. So this is the v the arrow. And so using this formula very, very quickly, the v dt, I've been told that is 18 pi. The v the arrow, I've solved and gotten 72 pi times the arrow dt. Now, can I get the arrow dt? Of course. To make this guy stand alone, 72 pi simply has to leave. So dividing both sides by 72 pi. Pi cancels pi. Can 18 go into 72? Of course. 18 here is 1. 18 in 72 is 4. But you don't have to do that. You can simply press your calculator and find that out. 18/72, which is the same thing as 1/4, is 0.25 meters per second. And that is option C. So this is how we deal with rate of increase or rate of decrease. Doesn't much matter which. Note the formula and apply. Okay. Next up, we'll go to the year 1999. and we take a look at question 29. Is our fifth question. And for this one, we are being told to find the value of x for which a function has a minimum value. So the value of x for which this function y equals to x cubed minus x has a minimum value. Now, as you are aware, to find that question, to answer the question we are given, step one, differentiate. dy dx will then be differentiating x cubed. 3 comes here. 3x, 3 minus 1 is 2. Differentiating x is 1. So 3x squared minus 1 is what I get. Next up, equate dy dx to 0. dy dx is 3x squared minus 1. Equate it to 0. Solving this, minus 1 will go to the right. 3x squared equals 1 over 3 over 3. So x squared equals 1 over 3. And to get rid of the square, we take the square root of both sides. X equals to square root of 1 is 1, and this is root 3. However, a common mistake we should know is that when we take square root, we assume the answer is positive. But in reality, there are two answers. There is plus or minus. Let's take the 1 as numerator, 1 over root 3. So in reality, the two answers you get whenever you find square root are positive value and negative value. So here my answers are either plus 1 over root 3 or minus 1 over root 3. So those are my stationary points. However, how do I know which one is maximum and which one is minimum? Because the question wants the minimum. So what do? I come here and say, time to differentiate again. The square y dx squared. The y dx was 3x squared minus 1. Let's differentiate this one more time. 3 times 2 is 6. Then x, 2 minus 1 is 1. So I stop there. Differentiate minus 1, that's 0. That means the square y dx squared is 6x. However, how then do I proceed from here? I'm going to then bring in these values. So first of all, let's try plus 1 over root 3. So the square y dx squared at x equals to 1 over root 3 becomes 6 times 1 over root 3, which is 6 over root 3. This is definitely a positive number, and as such, it is greater than 0. But on the other hand, the square y dx squared at x equals to minus 1 over root 3, the second value becomes 6 times minus 1 over root 3, which is going to be minus 6 over root 3. And as such, being a negative number, it is less than 0. So keep in mind, for maximum points, the answer here has to be less than 0, which means that this is going to give me a maximum point. And the one that is greater than 0 gives me my minimum points. So if you check your question, they want you to find the value of x for which the function has a minimum value. At which one was it minimum? You can see it right here. When x equals 1 over root 3. That doesn't seem to be my answer, but only because we did not rationalize. So doing that quickly, times root 3 over root 3 becomes root 3 times 1, root 3. Root 3 times root 3 is 3, which is option C. I hope we get this. I'll repeat it one more time for emphasis. Differentiate, equate that derivative to 0, and get your stationary points. Then to test these stationary points, find the square y dx squared. Then bring in your stationary points to represent x. If the answer you get is positive, this is a minimum point. If the answer you get is negative, then it is a maximum point. And that is all. Okay. Time to try the next one. And I believe that will be our sixth question underneath this topic. Okay, this one is from the year 1997, and this is question 11. For this one, we have been asked to find the minimum value of x squared minus 3x plus 2. They want the minimum value. Quite simple, remember. Looking for maximum or minimum, first step, differentiate. The y dx becomes, differentiating x squared is 2x, differentiating minus 3x is minus 3, differentiating 2 is 0. Once you get this, to obtain the stationary points, I equate the y dx to 0, meaning that 2x minus 3 equals 0, and then 2x equals to 3, which means x equals 3 over 2. Now, normally, it is at this point we go on to test the nature of these points. But do I have to waste my time testing this in my JAMB? No. Why is that? There's only one point. The question told me to find the minimum value. If there's only one turning point, then automatically this turning point must be minimum. They've already told me. Assuming there were two turning points, like in example 5, then I would have to know which is which. But since there's only one here, then it must be the minimum one. So to actually find the real minimum value means I have to put this into my original expression, meaning y becomes 3 over 2 squared minus 3 times 3 over 2 plus 2. 3 squared is 9, 2 squared is 4. 3 times 3 is 9 over 2 plus 2. For your addition, simply get the LCM. LCM will be 4. 4 into 4 is 1. 1 times 9 is 9. 4 into 2 is 2. 2 times 9 is 18. 4 into 1 is 4. 4 times 2 is 8. 9 minus 18 is minus 9. Minus 9 plus 8 is minus 1 over 4. This is my minimum value, and that is option A. So I hope we see the steps and how we can actually very easily obtain these values. Okay, let's have a couple more. This being the 7th one, and here we are going back to 1999, checking out question 30. Now for this one, all I have to see is that if the minimum value of y equals to 1 plus hx minus 3x squared is 13. The minimum value is 13. We already know it. We want to then find h. Let's try. As usual, dy dx would be, differentiate 1 is 0. Differentiate hx. H here is a constant, so it comes out. Differentiate 3x squared. 3 times 2, 6. X is power 1. And then as usual, for your stationary point, equates to 0. That means h minus 6x is 0. So h equals to 6x, and over 6 over 6, x must be h over 6. That means this is my turning point. And as such, to get my actual value, anywhere I see x here, I'm to replace it with h over 6. And I'm told, checking my question again, that this is the minimum value. So minimum value of 13 was gotten when x was h over 6. So this is 1 plus h. Where I see x, I put h over 6 minus 3. Where I see x, h over 6. But this is squared here. So that will be 13 equals to 1 plus h times h squared over 6 minus 3 times h, h squared. 6 squared is 36. Alright, what can I do? Let's collect like terms. 13 plus 1 goes to the left, minus 1. Why over here? Let's get the LCM. LCM is 36. 36 into 6 is 6. 6 times h squared is 6h squared. 36 to 36 is 1, leaving here as 3h squared. 13 minus 1 is 12. 6h squared minus 3h squared is 3h squared over 36. 3 here 1, 3 here 12. And so I cross multiply. H squared times 1 is h squared. 12 times 12 is 144. And to try to find the value of h, I take the square root of both sides. And there, h must be 12. And checking our question, that is option B. So you see, the steps for stationary points is truly this simple. Okay, so let's take one more. This time from the year 2000. The year is 2000. And the question, yes, I tried 2010. And the question is question 41. This one is asking, at what value of x does the function y equals minus 3 minus 2x plus x squared attain minimum value? It just wants the value of x when this happens, not the actual minimum point. I'm solving purely for x. But as is what stationary point, dy dx, first thing you do, differentiate minus 3 is 0. Differentiate minus 2x is minus 2. Differentiate x squared is 2x. And then dy dx equals 0. Meaning that minus 2 plus 2x equals 0. Take minus 2 to the right. 2x equals to 2 over 2 over 2. X equals 1. And that is the value of x when the stationary point occurs, meaning that my answer is option D. So you see, just to make sure we really have this down, though, I think we should look at one final example, and then we shall actually call it quits on this topic. This time we are going to the year 2005 and checking out question 39 for our 9th example. So for this one, we have been asked to find the maximum value of the function f of x equals 2 plus x minus x squared. But for our solving, I much prefer using y. So I can write dy dx instead of f prime of x. I like dy dx. So as usual, dy dx would be differentiate 2 is 0, differentiate x is 1, differentiate x squared is 2x. Then next step, equate dy dx to 0. 1 minus 2x equals to 0, and minus 2x equals minus 1 over minus 2 over minus 2. Minus cancels minus. Your stationary point is 1 over 2. And as such, to get this actual maximum value, which they asked for, we're going to put x equals to 1 over 2 into the expression. So how to get the difference now? If you just want to know the value of x when it is maximum, you stop here. But if you want to know the actual maximum or minimum value, then you put this x value you've gotten back into your question. The only time we test to know the nature of these values is when there are more than one values. If not, we just continue solving like that. So y becomes 2 plus, where I see x, I'm going to put 1 over 2, minus, again, where I see x, 1 over 2. But this time the x is squared. So 2 plus 1 over 2 minus 1 over 4. This is over 1, so the LCM is 4. 4 times 2 is 8. 4 into 2 is 2. And 4 into 4 is 1. 8 plus 2 is 10. 10 minus 1 is 9 over 4. And that is option A. So I really hope we've been able to actually get the applications of differentiation and how they can be applied in the different scenario depending on where you see them. So as such, it is time for us to take a few questions which you have to solve. Remember, you can find even more questions on the O3 Schools JAMB app. These are just few that I've actually helped you find. So you can start with these. So 2021 Model 2, question 22. 2001, question 37. 2009, question 38. 2002, question 22. And 2006, question 12. So simply try your hand on these, and if you're able to solve them, please comment as beneath this video right here. And you can also comment even if you're unable to solve, asking questions to which obviously will answer you. You can also remember to subscribe to this channel to see more videos explaining various topics across different subjects as you prepare for your exam. Get your 3 Schools app, activate it, and then solve as many questions as possible. Thank you very much for watching. My name is Athanasius.